You know, it's funny when you think about how our brains work. We don't just see the world like a slideshow, right? Isolated pictures.
No, definitely not. It's much more like a continuous movie. Everything flows, connects.
Exactly. Like following a conversation or a story or just reacting to something sudden. We're always building context, seeing how things link together.
Right. Our perception isn't just recognizing that thing right now. It's about seeing it in sequence, understanding its history, how it's changing. That's where the real meaning comes from.
And that leads us perfectly into today's deep dive. We're looking at something really exciting that tries to give AI that same kind of continuous understanding. It's called the Supertime Complex Neural Network, or STCNN. And we're focusing specifically on its sequential perception level. This is work that researchers like Gerardo Iovani and Giovanni Iovana have really delved into.
Yeah, and our goal today really is to explore how STCNN aims to get past the limits of, well, more traditional neural networks.
Limits like seeing things as disconnected bits.
Exactly. Think of it like this. Standard AI might see individual frames, but STCNN is designed to grasp the intricate connections between the frames, the temporal stuff.
So it gets a more stable, context-aware view of things as they change, like seeing the whole movie, not just the stills.
Precisely. We want to unpack how it processes information not just as it appears, but how it connects across time and context, how it builds that deeper meaning.
Okay. And we're drawing our insights today from a key paper, STCNN, Sequential Perception and Contextual Reasoning.
That's right. And it builds on important work from people like Tang and colleagues, Vermter and Leonard, Rowley, Ravenscroft. Yeah. Quite a foundation.
Okay, let's dive in. So starting right at the core problem. What's the fundamental challenge with older neural network models that STCNN's sequential perception is trying to tackle? What were they missing?
Well, the big thing is their limited ability to capture complex temporal dependencies, how things unfold over time. Right. Many older models, they either treat inputs as totally separate events, or maybe they look at very short time windows. STCNN is designed to move beyond that single-level snapshot way of thinking.
To get a more stable perception.
Exactly. A more stable, more robust understanding of the environment as it changes dynamically. It's about building a consistent narrative from the data flowing in.
That makes sense. Getting the full story, not just like a single headline. So how well does this sequential perception actually work? I mean, in the real world? Is it delivering?
It performs really impressively, actually. Take the study by Peng and colleagues. They used STCNN to classify driver fatigue from EEG signals.
Okay, that's a complex signal.
Very complex. And STCNN achieved 87.55% accuracy.
Wow.
But the number itself isn't the only story. What's really significant is how it got there. It showed the network could effectively model the temporal changes within those EEG signals.
So it wasn't just looking at one moment.
No, it incorporated the context of the whole, the way this signal evolved over time. And that's absolutely crucial for something safety critical like driver fatigue.
Yeah, 87.55% is definitely strong. But real-world stuff, it changes constantly. How adaptable is STCNN? Can it react instantly to new information, or does it lag?
That's one of its key strengths, actually. Its ability for dynamic, real-time pattern recognition. It reacts to input changes effectively.
So it keeps up.
Yes. And Peng's study also highlighted its robustness. During the learning phase, the accuracy varied by less than 0.4% across different test intervals.
Less than 0.5% variation. That's stable.
Incredibly stable, and that's exactly what you need for applications that demand immediate, adaptable responses in environments that are always shifting. It means it doesn't get easily thrown off. It understands the flow.
Okay, this sounds really sophisticated. How is it actually built? What's under the hood that allows for this sequential understanding and adaptability?
Well, the foundation is a hybrid connectionist symbolic architecture.
Hybrid, so mixing different approaches.
Exactly. Connectionists, like traditional neural nets, good at pattern matching and raw data. And symbolic, which is better at abstract reasoning and logic. This whole approach is linked to an emerging field called Sophimatics.
Sophimatics, okay.
And the core idea is to bridge the gap, to map those distributed neural representations, the raw patterns, to more abstract symbolic layers.
So it connects seeing the pixels, say, to understanding the concept, like bridging seeing a dog to understanding dog.
That's a good way to put it. It's about moving from raw perception to conceptual understanding, complete with nuances and relationships. It's quite a fundamental shift.
So does this mean it can learn beyond just what it's explicitly trained on? Can it handle genuinely new situations or interpretations?
Absolutely. That's where the hybrid approach really proves its worth. It helps STCNN learn sequences, words, actions, whatever, and crucially disambiguate inputs, resolve confusion. Even back in 1989, work by Vermeter and Leonard showed networks like this could interpret inputs with, and I quote, previously unknown semantic grammatical relations.
Unknown relations. That's impressive.
It is. They ran experiments, I think it was with prepositions, where the hybrid model correctly interpreted 77% of relationships it had never encountered before.
Wow. So it's not just memorizing patterns.
Not at all. It learns by abstraction. That's the key. It allows it to generalize, to integrate information over time, and understand associations even in new contexts.
Okay, this idea of building a deeper, context-aware understanding. It sounds like it's not just faster, but genuinely smarter, maybe more like how we think. How does it make sure it's seeing the connections, the bigger picture over time, and not just isolated moments? What holds it all together?
That's where something called cognitive ontologies come in.
Cognitive ontologies. Like a knowledge map for the AI.
Sort of, yeah. Think of it as a structured understanding of concepts and how they relate. Like we know rain is related to clouds and wet and umbrella. These ontologies provide that structure. So perceptual inputs aren't just seen in isolation. They get contextually and intentionally bound to everything that came before and even what's anticipated next. It creates that temporal thread.
And this helps it learn, grow.
Yes. It allows STCNN to model complex processes of cognitive growth. Its interpretation mechanism can actually change based on new evidence. It can sort of revise its understanding of past events based on what it learns later.
Like we do. We reevaluate things when we get more info.
Exactly. It mirrors human cognition in that sense. And research, like Ravenscroft's work on primate relational transfer, highlights how understanding these context-dependent relationships is fundamental for higher cognitive functions. STCNN tries to build that capability through context-aware abstraction.
It's fascinating how these parts work together. It's not just boosting performance numbers, but making the system itself more insightful and maybe easier for us to grasp, too. So it's about meaning, not just data, and sorting out confusion.
Precisely. A huge advantage of this sequential pattern recognition is how it interacts with symbolic reasoners.
The logic part of the hybrid system.
Right. During both learning and when it's actually working inference, this interaction lets it dynamically apply abstract, interpretable templates to figure out ambiguities in the data.
Can you give an example?
Sure. Look at work by Rowley and colleagues back in '95 on 2D image recognition. They found that hybrid systems, mixing neural and symbolic methods, clearly outperformed single-method approaches.
When? And what kind of tasks?
Especially when the task demanded abstraction and generalization, or when you needed the system to be interpretable to understand why it made a decision, and when it needed to dynamically apply contextual knowledge on the fly. That synergy is key for dealing with the messy real world.
Okay, with that kind of deeper understanding, it feels like STCNN could be really good at practical skills, couldn't it? Things like learning to use a tool or taking knowledge from one situation and applying it somewhere new.
Absolutely. That's a really promising direction. This architecture is particularly well-suited for things like tool use and transfer learning.
Why, specifically?
Because it aligns well with how we think intelligence develops. Both humans and potentially intelligent agents seem to rely heavily on non-linguistic codes and scenario-based problem-solving to learn and grow.
Non-linguistic codes, meaning not just language.
Exactly. Ravenscroft argued back in 2006 that true intelligent behavior needs this scenario-based reasoning, understanding situations, how things work together within them, not just manipulating language symbols.
And that fits with Sophimatics.
Perfectly. The focus is on understanding practical scenarios, using these underlying non-linguistic ways of representing knowledge. The system needs to grasp not just what is happening, but how the context is shifting, and crucially, how its own actions affect that context. That leads to a much more grounded understanding.
So let's tie this all together. If we zoom out, what's the big picture here? What is this whole approach, this sequential perception, ultimately achieve for AI? What's the real so what?
Yeah, stepping back, what does this mean for you, the listener, and how we think about where advanced AI is heading?
Well, the ultimate goal, the so what, is that STCNN's sequential perception isn't just encoding a stream of data points. It's designed to capture the contextual meaning, the intentional relevance, and the temporal progression of that data.
Okay, and why is that so important?
because it ensures that the downstream processes in the network, things like its context memory, its ability to reason about experiences, have the richest, most accurate context possible.
Ah, so the foundation is stronger.
Much stronger. It allows for truly grounded, context-aware abstractions and meanings to emerge. It moves AI much closer to how humans actually perceive and make sense of the world around them.
This deep dive really does highlight some significant breakthroughs, doesn't it? STCNN's sequential perception. Its ability to grasp those complex, time-based patterns, the real-time adaptability.
And that unique hybrid architecture enabling abstraction, not just memorization. Plus the cognitive ontologies for context, and its strength in scenario-based reasoning.
It really paints a picture of a path forward, doesn't it? Towards AI that doesn't just, crunch numbers, but actually understands information within its dynamic context. More like how our minds work.
Absolutely. And maybe that leaves us, and you listening, with a final thought to chew on. If AI like this can learn to interpret the meaning and the intent behind sequences of events, not just the raw data, what kind of new frontiers could that really open up?
Yeah, think about it. Personalized education that adapts not just to your answers, but how you're learning over time.
Or medical diagnostics that truly understand the progression of a condition, seeing subtle patterns unfold.
Or maybe even AI that can navigate complex social interactions with genuine nuance because it understands the flow, the history, the context.
The possibilities seem huge. It suggests the future of AI understanding isn't just about getting faster, but about getting deeper, more perceptive, maybe even more human-like.